In this video, we'll discuss verification versus non-verification failures, and we'll walk through main features of the Develocity Analytics dashboards. We'll begin by addressing a common challenge, understanding and mitigating CI build failures. As seen in this graphic, an increase in CI build failures directly impacts development velocity and time to market. By identifying the projects with the most instability, we can prioritize resources and address root causes strategically. Failures fall into two categories: verification and non-verification. You can filter build failures by verification or non-verification in Develocity Analytics. It is important to understand the difference between these types of failures to quickly identify the root cause of a build issue and assign it to the appropriate person or team. This distinction streamlines the troubleshooting process and improves overall development efficiency. Verification failures are issues that arise during the testing or quality assurance phases of a build. These typically indicate a problem with the functionality of the code, adherence to requirements, or the test infrastructure itself. Examples of verification failures include compilation errors, failed unit, integration or acceptance tests, linting errors, static analysis warnings configured to break the build. Implications of verification failures include code quality, defects or regressions in the application code, test suite health, flakiness in tests, poor test coverage, or issues with the testing environment. Team ownership requires developers to investigate and fix issues. Non-verification failures are errors that occur before or outside the explicit verification steps, typically related to the build environment or dependencies. Examples of non-verification failures include dependency resolution issues, environment configuration problems, resource exhaustion, network issues during dependency downloads. Implications of non-verification failures include build infrastructure, problems with the CI/CD environment, build scripts, or external dependencies. Developer productivity, the halting of development work entirely. Build engineer ownership requires intervention to resolve. Now, with this understanding of different build failure types, let's see how Develocity Analytics helps us quickly identify and address these issues in our CI builds. First, we'll access the Build Failures dashboard. This dashboard gives us a high-level view of build failures across all projects. It allows us to quickly spot potential bottlenecks from a management perspective. We'll get an executive overview. On the Build Failures dashboard, you'll immediately notice some key UI elements. On the upper left side of the dashboard, you'll see a series of filters relevant to the dashboard, such as build tool and project. These allow you to quickly narrow down the data presented on the dashboard to focus on specific technologies like Gradle or Maven or particular projects. Over on the upper right side of the dashboard, you'll find the date range selector. This is a critical tool for defining the time period of the data you're analyzing. Every Develocity Analytics dashboard is organized into logical sections. We start with a high-level overview to give you a quick summary of key metrics and overall health. Then, in the trends section, you'll see how things have changed over time, helping you spot increases, decreases, or stability in critical metrics. Finally, the details section provides the underlying raw data, usually in tables, which you can sort, filter, and export for your own in-depth custom analysis. By using the distinction between verification and non-verification failures, Develocity Analytics empowers you to quickly identify and fix the root causes of build instability. This not only streamlines your development workflow, but also gives a significant boost to your team's productivity.